Yes, hello, and welcome back to Mr. G's classroom. Okay. um, actually, let me get myself a piece of gum. Okay, that's about right. You guys, right now, you should be at part D, manipulating the y-axis, global warming, and Arkansas football. This part of the lesson. Okay, and right here where it says watch my first video lesson, there should be a link that links to this. Obviously, I can't put in there yet because I have not made this video. Most of the answers for the next several questions will be in this lesson, so please pay attention. So let's go back. You should have actually filled out this chart already, where you looked at blue marbles, red marbles, and yellow marbles in this group, right? And we got two different graphs, even though we use the same data, and I'll prove it. So if we change 15 here, right, you'll notice it actually does change a little bit. Let me give an example. Put 14 here, right? Let's make blue 4. You notice they did change on both the graphs. But on which graph did it change more? Let's see again. Let's just say red, right? So here's red, 18. Here's red's 18. Let's drop it down to, someone give me a number. 6, okay. So now when we drop this down to 6, we'll see which graph changes more, graph A or graph B. Oh, and you can see, I'll go back up to 18 too. Graph A significantly changes more. And that leads me to the first question. Even though these two graphs use the same data, why do you think they look so much different? Well, there's only one key difference I can see, and that's on the y-axis. We call it scaling. Graph's A y-axis only goes up to 20, while graph B's y-axis goes up to 200. So if you go here, I'll actually type in some answers for you. Right? That's the only difference. Let me just make this a little bigger. So the y-axis, A is scaled to 20 and B is scaled to 200. Okay, and so we actually talked about two-ray too. Which graph changes more extremely when you change the data? And we saw graph A changes way more extremely. It doesn't even look like graph B is moving sometimes. Now, you guys kind of see how we did this, like when we have two graphs, but we make the axis so big, it makes everything seem so smushed together. But the more spread out you make the axis, right, the more everything distributes. So, for example, instead of going from 0 to 200, we went from 0 to 1,000. Everything would look super, super smushed, okay? The question is, why do people do this? Why is this useful? Is this stupid? Well, I'll save you the answer. It is probably stupid to most of you, but actually I think this stuff is kind of cool, and that's why I'm teaching it. So, for example, let's say you're a toy company that sells red marbles, and you want to put one of these graphs in your ad. Which one are you going to put? Keep in mind, this is how many marbles kids buy. Well, let's look. Graph A looks like red marbles are pretty popular compared to blue marbles and really popular compared to yellow marbles. Graph B looks like not much difference between red and blue, and maybe a big difference between red and yellow. So if I were a company that sold red marbles, I would use graph A because it makes the difference in marbles bought seem more extreme compared to graph B. So I would say I'll use graph A because it makes red marble sales seem larger. Okay. So basically you can use the graph to tell your story. Now, let's say I was a company that sold yellow marbles. Which one would I want to use in an ad? If I look at graph A, it makes it seem like yellow is extremely unpopular compared to blue or red. But if I look at graph B, it's like they're pretty close. So if I were a yellow marble salesman, I would use graph B because the differences seem, how would you say it? The differences seem smaller. Yeah. Yellow's not that far behind. Okay, and while, like I said, this is like just marbles at Franklin, I kind of made it up. We actually do see this thing all the time. And companies will just literally just change this y-axis to make graphs suit what they have to say. So I think the next thing that you guys have is, it should say global warming graphs. Okay, yep. So I don't need this. I'm actually not going to type in these answers for this one, so you really have to listen and pay attention to my voice. And I have to say, it's like, I mean, today, maybe not, but my voice is much more rested since I stopped teaching because I don't have to scream as much, which I kind of miss, to be honest. But yeah, this is kind of cool actually because global warming, right? I would say the majority of people in this world believe that global warming exists, and I'm not saying if you do or you do not, but there's a good chunk of people who dispute that, including our president. And so you will see these graphics, infographics, charts throughout social media, throughout magazines, and they're going to try to prove their point. And this is how they do it. Just like with our marble example, both of these graphs are using the exact same data, right? Why do they look completely different? Graph A looks like kind of like a straight line, right? So this measures the average global temperature from 1880 to 2014. And if you look at graph A, it just looks like the average temperature did what? Stayed the same. Kind of like, you know, like people's voices are supposed to get deeper. Well, mine just stayed the same. I am just graph A. Okay, so let's just keep that in mind. Now, graph B, right? Graph B looks like the temperature's fluctuating quite a bit and actually rising ever so slowly as you get to present day time. What's the difference? Once again, it's the y-axis. Graph A's y-axis starts at -10 and goes all the way up to 110 degrees. Graph B's y-axis starts at 55 and goes to 60. So the question is, they're both correct. Why do you think they look differently? Oh, we said y-axis. Right, A on the right from negative, goes from negative, sorry, crap. and B goes from 55 to 60. Now, the question is, which one's better? This is maybe, I want to say opinion, but more than opinion. If you think about average global temperatures, as you can see from this graph, they're all between 55 and 60 since the last 150 years. So graph A, what they did was they zoomed out, so it looked like everything was really flat. So I would say graph B is better because you don't get to, global temperature is not going to rise 20 degrees in 10 years. It's going to be really, really slowly, okay? And you're not going to see that slow rise in temperature if you zoom all the way out like graph A did. So I'd say graph B is better because it's zoomed in to really, you can really look at the differences. Now, number 3, I'm not going to write that, so you guys, that's my opinion. You can say what you need to say. Who would probably want to use graph A? People for global warming or people against global warming? So like, if you look at graph A, right, what's it saying? It's basically saying there has not been any global warming. So think about that. In my opinion, graph B says, look, it's kind of up and down, little spike there, but what's happening? What's the trend right here? It's going up. So same data, 2 different messages. And I think you guys had a fourth. Oh, number 4 is just saying how often you get fooled by these graphs. Pay attention. See if you can find some on the internet today, tomorrow. And then the last thing is kind of the same exact concept, just looking at the y-axis, but for an Arkansas football team for the last 15 years. So then you guys can just answer these last 3 questions. Obviously, we're going to be doing a little bit more of this and looking at different types of graph manipulation. The whole point of this lesson is for you guys to become informed. So when you see a graph, you just don't take it as face value. When you guys see a graph on global warming, you're not just like, oh, that makes sense, of course. You'd be like, actually, it's probably not the best graph to use. So, good luck. Call me, FaceTime me, text me, message me if you have any questions. It's always a pleasure doing business.